Okay, this is normal probability distributions, and my Microsoft has decided to crash today, so that's been fun. But anyways, so I'm going to try to do this on a Prezi, but I've actually never used it before. But so anyways, so the PowerPoint, you'll be able to pull up the PowerPoint and it should work. Mine was not working. So, and I'll show you these pictures here in 1 second, but we have the curve of a normal distribution. So this is a normal distribution, and we sort of talked about this when I did the Super Bowl points that were scored. It's the same thing there where I talked about standard deviations and we mentioned the empirical rule, and I said on that we'll come back to it later. So anyways, the curve is bell-shaped, and this goes right along with the PowerPoint with the highest point over the mean mu. It is symmetrical. I'm just going to fill in all these blanks and then I'll show you a picture about the vertical line through mu, and the curve approaches the horizontal axis, but it never actually touches or crosses it. So those blanks are on the PowerPoint, and just to show you I thought I could just click on this and it would like open it up. Maybe. Oh, maybe let me do it over here. Okay, there we go. Sorry. So the normal curve goes up and comes back down. It's bell-shaped. The highest point is over your mean, which is mu. And then these are your inflection points. You got the upward and downward cut, but those are the properties of your normal curve, normal distribution. And we have the empirical rule, which is what that Super Bowl points was. So let me just pull up, click on the wrong thing. Let me just pull up this one here. So I did this with the Super Bowl points to show you that the empirical rule is true, where if this is your mean plus the standard deviation, this is your mean minus the standard deviation. 68% of your data will usually be within one standard deviation. So to fill in these blanks, the empirical rule only works on normal distributions, so they have to be bell-shaped. So approximately 68% is within one standard deviation. 95% is within two standard deviations, and then almost all, which is 99.7%, is within 3 standard deviations. So going back over here to the picture, here's your normal distribution. So 68% is within 1, 95% is within 2, and almost all of it's within 3. So we've talked about that before. So to do an example, we have the life of a particular type of light bulb is normally distributed with a mean of 1100 hours and a standard deviation of 100 hours. Now, usually for these, you're always going to want to draw a normal curve. Makes things a little helpful. Well, they don't have to be perfect. Mine usually don't look too pretty, but it's okay. What is the probability that a light bulb of this type will last between 1000 and 1200 hours? So if you were going to fill it in down here, your mean is always below this highest point here. So our mean, it tells you, is where to go? Over here, 1100 hours. So here's our mean at 1100. If I add a standard deviation, it's 100 hours. So if I go up 1 standard deviation, I would be at 1200. And if I go down 1 standard deviation, I would be at 1000. So let me just draw a line here and a line here to show you where I'm at. If I added another standard deviation, I would be at 1300, 1400, or if I took it away, I'd be at 900, 800. You could keep filling this in, but for this particular problem, it wants to know something about 1000 and 1200, so I have those. So it wants to know, what's the probability that you're somewhere in here between 1000 and 1200? Well, we just said 68% is within 1, so this would be 68%, just using that empirical rule. So what we want to do, if I can find it here on the screen, maybe, if I can back up enough, let's see. What we want to do is, okay, something called the standard normal distribution. It has a mean of 0 and a standard deviation of 1. So when you're given a data set, your data, depending on what your data set is, it's all going to be different means. This mean was 1,100 hours. You might have a mean of 700 hours, 500 hours. You might be talking about money and the mean is $3.25 or something like that. So what we want to do is to be able to convert it to one thing that's the standard normal distribution, which always has a mean of 0 and a standard deviation of 1. So all of your x values are converted to z-scores by the formula z is equal to your data value minus your mean divided by your standard deviation. So all of your x values get converted. The z-score tells us the number of standard deviations between the original measurement and the mean. So like for this one would have a z-score of 1 because it's 1 above the mean. This one would have a z-score of -1 because it's 1 below the mean. So I have if I click, there's a couple charts that are useful. If your x value is the mean, your z-score will be 0. If your x value is greater than the mean, your z will be greater than 0. And if your x value is less than the mean, your z will be less than 0, be negative. There's another one somewhere if I can find it here. Let's see. I don't think it's on that one. Because I've never done Prezi before. I'm doing all kinds of stuff I've never done in this class. Here we go. This is what oops, wrong. I don't know why I can't click over there. Okay, so what the importance is to note is that so this is any normal curve. So it's any curve that's bell-shaped, it's normal. It may go real low, may peak really high and come back down. So any normal curve, if you convert it to the standard normal, which has the mean of 0 and standard deviation of 1, the areas will be equal. So you'll be able to do calculations using your standard normal curve. And so you're going to see that in just a minute when we get to a problem. Okay, so that's why that is important. So what we want to do is the amount of time it takes for a pizza delivery is approximately normally distributed with a mean of 25 minutes. And you can get in a habit of writing down mu and a standard deviation of sigma. It'll help you later when you do stuff because you need to be able to label and read the problem and translate it. So we want to convert 21 minutes into a z-score. So we're just going to use this formula here. So we do 21 minus my mean, which is mu, 25, divided by my standard deviation of 2. So that is -4 divided by 2 is -2. So that is the z-score. So 21 is 2 standard deviations below the mean. If I want to do 29.7 minutes into a z-score, same thing. I'm going to use the formula. So I've got 29.7 minus the mean divided by my standard deviation, and I get 2.35. So 29.7 is 2.35 standard deviations above the mean. Now, for your z-scores, you're always going to round them to 2 decimal places. So unless, it comes out to like a whole number, but 2.00 it would be equivalent. But you always want to round those to 2 decimal places. Okay, so now what happens if you have a z-score and you want to know what's the original value from that, then that is your raw score. So your raw score is the result when you convert from your standard units back to your original z values. Back to your original x values. And you use the formula. This is the formula z times sigma plus mu. And the reason that's true is because we just said z was x minus mu divided by sigma. So if I solve for x now, I multiply by sigma on both sides, so I get z sigma is equal to x minus mu, and then I add mu to both sides. which leads me to x is z times sigma plus mu. So you don't have to memorize these formulas. You do just need to know when to use them. So if you have a z and you want x, use this formula here. If you have x and want z, use the z-score formula. So you want to interpret a z-score of 1.6 if the same thing, the pizza delivery thing, 25 minutes and standard deviation of 2 minutes. So what does this correspond to? If the z is 1.6, then I want to know what x is. So I'm going to do z, which is 1.6, times sigma, which is 2, plus the mean, which is 25. So that would correspond to a time of 28.2 minutes. So you can convert back and forth to get z-scores in your original data values. So what we want to do is to be able to calculate probabilities, just like we were doing with the probability distributions and the binomials, the binomial distribution. We want to know what's the probability that something occurs. So just like, you know, in medical cases and test scores, you know, if you need to have a certain test score, you want to know what's the probability that you'll be above, I don't know, like if you want to get into a really good college, you need to be 2 standard deviations above the mean. So anyways, you want to find out some of those values. So there's a couple ways to do it, like everything else. There is a chart for z-scores that is posted in the course, and I'm going to show you that. You can also do it on the calculator, on the TI calculator. You can also do it on Desmos. And I actually really like Desmos simply because it gives you a graph. So you can do it different ways. So if we want the probability that z is less than 1.27, then you need to get into a habit of drawing a sketch. For these, it'll ask you to do it on your homework, so don't forget that. So remember, 0 is always here in the middle. So 1.27 would be like here. That's 1.27, and if you want it less than, you want to know what is that area, what is that? Probability and area are interchangeable here. So if you want to use the chart, which is fine, you can open the chart up on the course. My mouse quit working too. Technology's hated me today. Oops. I want to go to the positive side. So you see, here's your chart. So this is for z's negative 3.4, and this is for the z's positive. Once you get to 0, switches over to positive. So if we want, and it tells you to at the top, it's for the left-hand side. So we'll talk about that in here in just a second, but you basically need, the chart is only telling you the area to the left, or the probability of less than. So that's all the chart gives you. So if you have a less than, or area to the left, if it says find the area to the left, then you can just take the number off the chart. So I'm going to look at 1.27. So I go to z is 1.2. And then I go over to 0.07, so you see kind of now why we round z to 2 decimals. That's what the charts do. 0.8980. So this is 0.8980. So now let me talk about the calculator. So that's using the chart. Let me talk about the calculator and Desmos. The calculator and Desmos both need a minimum value and a maximum value in order to tell you the area. So the maximum value in this case would be 1.27 because that's where the line here stops, right? The minimum value, remember this keeps on going on and on and on and on and on, and on forever, but it never actually crosses this line. So you've really got, not -8, meant to make an infinity sign. You really got negative infinity out there, but we can't really type in negative infinity. So you just want to type in negative 1,000. Some people use 10,000. I've never had a problem with 1,000. So on the calculator, what you'll do, if you want to use the calculator, you go to, maybe if it'll cut on, or you quit working too. Of course you did. Why would you work? Let's see. Maybe I can bring it back up and it'll work. So on the calculator, let me get rid of that one, open up another one, if I can remember where it is. See, I just have 2 calculators on the screen, that's okay. Okay, so on the calculator, oh, this one, why is it not letting me do touchscreen? Okay, maybe it will. Please cross your fingers. Okay, you're gonna go second, hello, second, nope, I'll try it with the pen, second. Well, how does it work sometimes? I don't understand. Okay, anyway, second bars. And then you always pick normal CDF. So go down to number 2 or press number 2. I don't understand why this touch screen's not working either. Might have to. Hello. Come on, work please. 2, nope, 2. I want number 2. Okay, let me see, the mouse works for a second and then it quits working. Okay, let me just restart it real quick. Sorry. Let's see if there's something else we can do. We can, how about we just draw all these here while that restarts. So we'll draw these and then I'll go back to the calculator. So the area to the left of Z is negative 1.65. So again, you have a normal curve. If it's the area to the left, so 0, remember, is always in the middle here. Now try not to label too much, I don't want it too crowded, but negative 1.65, you're doing something like this. And that's the area to the left. And then for this one, we have the probability that Z is less than 1.64. So again, 0's in the middle, so 1.64 would be somewhere like here. And that's the area to the left. So when on your homework, when it says to sketch these, you know, you don't have to be too accurate. I'm obviously not very accurate, but anyways. So the probability that Z is less than negative 2.71, so here's 0. Negative 2.71 would be down here somewhere, and we want that area. So for these, we can use what I was saying here, the negative 1,000 to a Z, which I'll show you here in just a minute once the computer decides to work again. Or you can use just the chart. You find that value on the chart and it tells you the answer and you just write it down. For the next few, those are if you want Z to be between two values. So for this one, we've got between 0 and 1.24. So here's 0, and here's 1.24, roughly. And so we want the area between those. So if you're doing the calculator, like I said, the calculator needs a minimum and a maximum. So there's your minimum, there's your maximum. So you don't have to worry about this negative 1,000. Desmos also needs a minimum and maximum, so same thing. The chart only tells you to the left. So for the chart, this is where it gets a little bit tricky if you use the chart, because the chart's going to tell you to the left of 0, which, remember, this is normal and it's symmetrical, so 50% has to be to the left of 0 and 50% has to be to the right of 0. So 0 is 0.5, and then it'll tell you to the left of 1.24, so it'll tell you all this. So what you have to do is, if you use the chart and not the calculator or Desmos, you would have to subtract, because it's going to also give you this. So it gives you 1.24 all the way down and 0 all the way down. So you'd have to take the value at 1.24 and subtract off the 0.5, which we'll do here when my computer works again. So if you want to do, so we're just going to draw these, and like I said, we'll go back and fill them in. I apologize. So we've got up to 0, so here again in the middle, 0. Negative 2.37 is kind of down here. Maybe not quite that far, but it's okay. So we want between those two, between negative 3 and 3. So remember for this, if you go back to the empirical rule, we can do this one without anything, because almost all of your data, or 99.7%, falls within 3. So that one we know the answer from the empirical rule. So we got down here's negative 3, up here's 3. So this should be, and usually for probabilities, if it asks you probabilities or area, unless it tells you to do percent, you're going to write it as a decimal, and you're going to do 4 decimals. So it's always 4 decimals for probability or area, 2 decimals for z-scores. Okay, so that one we know, this is just using the empirical rule, so I didn't even have to look for that one. I have to open everything back up, but anyways. So this one between negative 2.34 and 1.57, if we draw that one, we've got negative 2.34 is kind of down here, 1.57 is sort of there, and we want that area or probability. One more in between, we got negative 2.44 and negative 0.73. So here's 0 in the middle. So negative 0.73 is probably about right there. And negative 2.44 is here. And we want that area or probability. Like I said, they're interchangeable. And then if you want a greater than, that would be the area to the right. So we got 2.39. Made that a little high, but it's okay. So the area to the right, so again, the chart only tells you to the area to the left. So if you're going to do the area to the right, you're going to do 1 minus, just like we did when we were doing the binomial distributions, and you have to do less than. For your calculator, out here is positive infinity. So you're going to give it a minimum and a maximum, but you can't type in infinity, so you're going to type in 1,000 or 10,000 or whatever. Same goes for this one. So if you want greater than negative 1.43, which is about right there, we're going to go from negative 1.43 out to like 1,000. Okay, so let me show you on the calculator. Let me pull this stuff back up here. And I'll show you on the calculator, and then I can show you on Desmos, maybe, and I can show you on the chart how to do the subtraction ones as well. Not sure why it's opening PowerPoint. It's probably going to try to open everything that I had closed. Because why not? So on the calculator, you do what I was trying to show you. Oops, close, go away. What I was trying to show you, so let's go back to the first one here. So you go to second vars, and you go to normal CDF, which is number 2, always. And that's where I said you have to put in a minimum. So we're going to do negative 1,000 or 10, oops, missed the one. 1,000 or 10,000. I've never had an issue using 1,000. And if we go back, we're doing example number 1, we'll go back to it. So 1.27. And hit enter, and it's and you always round these to 4, like I said, so 0.89795, so 0.8980, which is the exact same thing that we got from the chart. So that gives you the same answer. If we go to Desmos, maybe, if we go to Desmos, the way to do it on Desmos, and I don't have it typed out on the notes yet because, like I said, my whole Microsoft just crashed today. So I like technology, you know, when it works. But anyway, so to do it on Desmos, you want to go over to functions. Probably help if I film it. So functions, and then you want to go to distributions, and we are doing a normal distribution. So you pick normal distribution, and it gives you a nice little graph. And then what you want to do is if you click on find cumulative probability, so see, I guess you can put in negative infinity for Desmos. It's okay with that. I didn't notice that earlier, but our max is 1.27, and there's our probability, and it gives you your graph, so you even know what to draw. So I actually really like Desmos because it also gives you the graph. Okay, so if I can get back into Moodle and open up that chart so we can do, oops, the rest of them here. Actually, I'll go ahead and do a few more on Desmos just because it gives you that graph and you can kind of see it compared to my graph. So the next one's area to the left of z is equal to negative 1.65. So again, we're going to type in, well, if you're using the calculator, you got to type in negative 1,000. Desmos lets you do the infinity. So we want to just change now. All I'm going to do is change our max to negative 1.65. And it tells me it's 0.0495. Like I said, you always round to 4, and it shows me my graph. So there's my little hand sketch. So, let's zoom in just a little bit if it'll look. Oh, that's a little better. So there's if I zoom in a little bit. And on the calculator, what I would do is I can hit second enter so that I don't have to go to second vars and pick normal CDF again. And then I change my 1.27 to negative 1.65. And I get 0.0495. And excuse me, on the chart, when I get back to it here, maybe on the chart, I get one down. It's taking forever to load. My internet's slow. Here we go, the chart. So on the chart, I look on the negative side, which is this first page, and I go to negative 1.65. So I go to negative 1.6 over to 0.05, which is here, which is 0.0495, and you're done. So now you don't have to do it all 3 ways, but we did it all 3 ways and got the same answer, so it's always good. So for the rest of these, I'll just do it on Desmos, because like I said, it's nice that it gives you a graph and you can pick which way you want to do it. So less than 1.64, I'm just going to change my max to 1.64. On the calculator, I would do second enter again and change it to 1.64, and I get 0.9494. Sometimes these, or 0.9495, sorry, I gotta round up. Sometimes these numbers run together, and there's the graph. On the chart, just to show you, I'll show you the chart real quick. 1.64, 1.6 over to 0.404, 0.9495. Sometimes I was gonna, that one's not, doesn't do it, but sometimes this will be, no, that's not true. It's when you subtract. Sorry, ignore me. Negative, for number 4, it's negative 2.71. So if I use the chart, I'm just going to use the chart since I got it pulled up here. So negative 2.7 over to 0.01 is 0.0034. On the calculator, I would just change it to negative 2.71, or on the Desmos, I would change my max. So now when we get to here where we have to subtract, this is where I was going to make mention of the decimal rounding thing. So for this one, 1.24, so if I use the chart for this, I have to go down to 1.24. 1.2 over to 0.04 is, I think that one, 0.8925. I scrolled down too far, I can't read my 1.2 over to, yeah, 0.8925. So I will do it minus, because remember that gives me all of this, that including the pink. So I want to subtract off to the left of 0, which is 0.5. If you don't believe me, you can look on the chart, it's 0.5. So minus 0.5, and I get 0.3925. If you use the chart and subtract, sometimes this last number will be different compared to if you do it on Desmos, where we're going to now change our minimum to 0 and our maximum to 1.24. And it shows you this graph, and it's 0.3925. So this one's not a rounding difference, but sometimes you will have one. On the calculator, you would do the same thing, second vars, number 2 again, always number 2, normal CDF. You don't have to worry about PDF or CDF here. And you do 0, comma, your min, comma, your max, negative, or not negative, what was I doing? 1.24, positive 1.24. 1.24, and it gives you the same thing. So for the next one, if you wanted to do this one using the chart, you would take 0.5, which is the 0 minus whatever the value is at negative 2.37. For the sake of time, I'm just going to type them in on here. So negative 2.37 and 0. Because probably most of you are probably going to want to not subtract, because you might forget to subtract. So 0.4911, and there's your graph. For the next one, we had negative 3 to 3, and just to prove it to you, since we already answered that one for the empirical rule, negative 3 to 3, 0.9973. I put 70 because I couldn't remember the last decimal, but I can change that to a 3, but 99.7%. So I'll just write a 3 over that, but you know, we were pretty close. For the next one, we have negative 2.34 and 1.57. So again, I'm going to change this. And remember, if you want to use the chart, that's fine. You just need to subtract the bigger one minus the smaller one. So you get 0.9322. 0.9322. And then for the last one that's between, we have, and on the calculator you do the same thing, you're just changing your mins and your maxes. So negative 2.44, and my max is negative 0.73, and that gives me 0.2254. So, and then there's my graph as well. And then what we're going to do for the last one, so like I said on this one, so if you want to use the chart for greater than, you have to take it away from 1. So like let me do that first since we already talked about that. If we do the chart, okay, literally we're just working fine. Okay, there we go. If we do the chart, you have 2.39, so over to 2.39, which is all the way over. That's 0.9916, but remember that is to the left of 2.39. We want to the right, so we have to take it away from 1, so that gives us 0.0084. So on the calculator, you would go back to second VARS, normal CDF still, and now your max, we already said was infinity, so we're going to make it 1,000. So I'm going to do my mins 2.39 because I'm going to the right, and my max is 1,000 or 10,000, and you get 0.0084, which is the same thing. On Desmos, if I go back over to Desmos, my min now is going to be 2.39, and my max is infinity, which is somewhere. You can put it in apparently. I don't know where it is. I feel like I'm doing pretty good with Desmos considering I've never done it, but I have no idea where infinity is. It's somewhere though, because it was there a minute ago. So anyways, I'll just type in, somebody else can tell us where it is. I don't see it right off, but I know it's here. Miscellaneous, no. I don't see it. That's okay. We're just going to type in 1,000 and, oh, it put it in for me. Okay, I don't know how I did that, but anyways, 0.0084. I guess it puts it in automatically. I don't know. I didn't click anything. So anyways, and then for the last one, finally, is greater than negative 1.43. So I'm just going to change my min to negative 1.43, and it's 0.9236. And again, go away, and then again, the graph is given to us here. And on the calculator, you could do the same thing. You could do, excuse me, I got the hiccups, normal CDF, and then go back, make it a, if you had a positive and you want to make it a negative, when you do that, it's going to mess you up unless you do the insert thing. Usually I just end up typing over it all. But it'll give you 0.9236 as well. Okay, so the application of those, finally, we have, so same thing, pizza delivery, right? You want to, it's the same mean, 25-minute standard deviation, we've not changed it. If you order pizza, what's the probability that the delivery time will be between 25 and 27 minutes? So you could do this using 25 and 27, but we want to use the standard normal. And you see here on this, unless you change it, this is using standard normal, means 0 standard deviation of 1. So what we want to do is calculate our z-scores. So my first z for 25 is 25 minus 25 divided by 2, so that's 0. Remember, if your mean, if your x value is your mean, your z-score is 0. And my second one is 27 minus 25 divided by 2, so that's 1. So I want to know the question between 25 and 27. So the probability that x is between these two is the same thing as the probability of z being between 0 and 1. Those are equivalent statements. So I can do that. Again, you can use the chart if you remember to subtract. You can use the calculator and do 0 to 1, or you can use Desmos. And because Desmos gives me a graph, I'm just going to do it this way. So it is 0.3413. So that is the probability that the mean delivery time will be, that the probability that the delivery time, not the mean, sorry, the mean's already given to us. The delivery time will be between 25 and 27 minutes, which is the same thing as 0 and 1 if you're doing your standard normal. And then there's my graph. So you can draw that picture. If we want the probability that it'll be less than 22.7 minutes, so that would be, we find our z, we take our data value, 22.7, minus the mean of 25, divided by the standard deviation of 2, which is, and remember for z, you always round to 2 decimals, so negative 1.15. So the probability that x is less than 22.7 is the equivalent of z being less than negative 1.15. You could use the chart, or you could do Desmos. So if I type in my max now, because I'm doing to the left, negative 1.15, yell at me here in a minute. Then, yeah, it does that automatically because I just clicked off. So 0.1251 is the probability that it'll be less than 22.7 minutes. So these are usually multi-step problems. You just have to read carefully and make sure you know if you're going from x to z and then probability or whatever the case is. Now, what happens if you actually have the area and you want to find z? So this is our last page here. So the inverse normal probability distribution. If you are given an area or a probability and you're trying to find your z-score or your raw score, you go z first and then you use the x equals z times sigma plus mu to find the x. So you're going to use second vars, which is inverse norm, on the calculator. Now Desmos has a thing, and I'll have to post the link. I could not get it to do it. I typed in, what did I type in? I had it open until the computer went berserk on me. Inverse norm, Desmos. You can search this, and I'll post the link in the teaching tips. Because it has it, this one. It has somebody's already done a program, I guess, for it, and so it gives it to you. So anyways, I'll show you how to do it both ways if you want to use the Desmos link. So the thing is that when you use the inverse norm on the calculator, or just like we were talking about with the chart, it only gives you the area to the left. So if this tells you that the area to the right is 0.01, then you know the area to the left. Remember, the area under the whole curve is 1 or 100%. So if this is 0.01, then this is 0.99. So when you do this on the calculator, you always type in the area to the left, whatever's over here. So what we go to is second vars and inverse norm, which is number 3, and put in 0.99. That's the area to the left. So my z-score is 2.33. You round z's always to 2 decimals. Okay. So if I'm given the area to the right, I can subtract it from 1 to get to the area to the left, and I can do that in my inverse norm. On Desmos, this tells you enter probability P and then Z returns a value so that the area to the left of Z is P. So I'm going to enter oops, nope, not that. 0.99, that's what I was trying to do. And then you find Z, let me think about where it was. Here it is. It is this down here, it says X, I don't know, XL, and it says it's 2.33. That's where it is. That's Z, that's what we got. So this is the same thing, but anyways, there it is. So it gives you the same answer this program does. It's just kind of, you have to sort of search for it. So then, what if you're given the area in the middle? If you're given the area in the middle, so this tells us our area in the middle is 0.7814. Okay, well then that means how much is in both of these? If we know the middle is 0.7814, if I do 1 minus 0.7814, I get 0.2816. So these two things combined have to be 0.2186, right? Because the whole thing has to add up to 1 or 100%. So if this is 0.7814, this has to be 0.2186. Well, remember it's symmetrical, so the same amount has to be here as here. So how do I get that? I divide it in half. So if I divide that in half, I get 0.1093. So I've got 0.1093 over here, and I've got 0.1093 over here. So now all I gotta do is go to inverse norm. And the beautiful thing about the normal distribution is it's all symmetric. So I'm gonna do inverse norm, 0.1093. That gives me negative 1.23. Well, if this one's negative 1.23, because it's symmetrical, this one has to be positive 1.23. I could also get that by doing inverse norm of 0.7814 plus 0.1093, but it's symmetrical, so it has to be true. Those have to be one's negative, one's positive. On Desmos, again, if I type in 0.1093 and scroll down, it should tell me negative 1.23. And again, it gives me all these decimals, but z-squared just rounded to. Okay. So for the last one here, like this, 99%. So this is 99% or 0.99, which means how much is left in the tails. So in the tails, if I do 1 minus 0.99, I've got 1% or 0.01. So this is 0.01. So half of that has to be here and half of that has to be here. So I should have 0.005, sorry. So 0.005 in each. So again, I can do either change that P on Desmos, or I can do second bars inverse norm and do 0.005, and I get negative 2.58. And then again, because it's symmetrical, then I'd have to have the positive. Okay, so the reason this is helpful is because here's an SAT score. The mean is 500 and the standard deviation is 100. Scores are normally distributed. A major university determines that it'll accept only students whose verbal score is in the top 4%. So what is the minimum score that you must earn? So here's where it would be helpful to know this, because if you want to be in the top 4%, what does that mean you have to get? So here's the top 4%. So I want to know, what is the X value for that? What's the score? Well, I'm going to get Z first, right? So if this is 4%, this is 96%. So I can go over here and I can do inverse norm. Second var's inverse norm of 0.96. And that gives me Z, it's 1.75. So, okay, I'm not done though. Because I'm not I'm not completely finished. Z is 1.75. Well, that's fine. That means I need to be 1.75 standard deviations above the mean, but that doesn't answer the question. What's the score that I have to have? So to find X, I do 1.75 Z times sigma using that formula. So sigma is, somewhere I told y'all you leave these, means 500, sigma is 100. So 1.75 times 100 plus 500. So 175 plus 500 is 675. So you'd have to have a minimum of 675 in order to be accepted into that university. Okay, so just a few additional examples here, and then there's also an example video that'll be helpful for your homework. But just to finish out these notes, you have a pediatrician obtains the heights of her 203-year-old female patients. The heights are normally distributed with a mean of 38.72, so there's my mu, and standard deviation of 3.17. What percent have a height less than 35? So we want to know what percent have a height less than 35. So again, find Z first. So Z is 35 minus my 38.72, my mean, divided by my standard deviation. So if I do that over here, I get 35 minus 38.72 divided by 3.17. So that's negative 1.17. So the probability that X is less than 35 is the same as the probability that Z is less than negative 1.17. So when I do this on the calculator on Desmos, again, if you want to draw it, here it is, negative 1.17. I can either do my negative 1,000 thing. If I'm doing the calculator, I can use the chart, or I can go back and use Desmos. Like I said, I like Desmos simply because it gives me a nice little graph. So negative 1.17, it's 0.1210. So this is 0.1210, but it actually says what percent, so I want to convert that to percent. So 12.1% would be the answer. Then it says compute the probability that if they randomly select a female, 3-year-old female, then they would be between 35 and 40 inches tall. So if we do that, we're going to have two Z's. So my first Z will be, so this is, let me write this over here. Probability that X is between 35 and 40 is the same as, so I've got 35 minus my mean divided by my standard deviation. That's my first Z. And my second Z, so I can type them all in at one time. Okay, so 35, let me go to my calculator. So I've got 35 minus my mean of 38.72 divided by 3.17 equals negative 1. Oh, I already did that one. Look, I'm just typing it again. I wasn't even paying attention. Negative 1.17. We already did that one in the first one, but anyways. Like I said, it's always good to verify things. 40 minus 38.72 divided by 3.17 gives us 0.40. So the probability that X is between these is the same as Z being between negative 1.17 and 0.40. So again, I can do normal CDF. You can use the chart and subtract, or you can go here on the calculator and do negative 1.17 and 0.4. And then there's my graph if I were to draw it. So I get 0.5344. And this one just says probability. If it just says probability, you can leave it as a decimal out to 4. If it says percent, you want to switch to percent. So find the z-score so that the area to the left is 0.32. So here's the area to the left is 0.32. So what I'm going to do is inverse norm on the calculator, or you can use that Desmos program. So I'm going to do inverse norm of 0.32. That gives me Z is negative 0.47. And for our last one, the Z-score such that the area to the right is 0.4332. So if I want the area to the right is 0.4332. Remember, the inverse norm can only do the area to the left, or that Desmos program only does area to the left. So you can, instead of doing 1 minus and writing it down, you can do second inverse, or second var's inverse norm, and type in 1 minus 0.4332. It doesn't care. So Z is 0.17. Because if you do 1 minus 0.4, so if I do the inverse norm of that, I'll get the same answer. So it doesn't care if you want to do 1 minus in the, if you want to do 1 minus in the inverse norm, or if you just want to figure it out. So this over here was 0.5668, so Z is 0.17. So there's calculator notes on the very last page. And I need to add the Desmos notes. Like I said, my Word quit working. But Desmos, it's in the video, but I'll show you, I wrote down some of this. Desmos, your function, go to functions, normal distribution, click the box to find this, and then your min, I wrote this down because I didn't realize it did negative infinity. It'll automatically put the infinities in for you. So you type in your min, your max, and you're done. So if this is, so you'd use negative to the infinity if you're doing less than or to the left, positive infinity if you're doing greater than or to the right. So that's it for the notes, and so you'll have the homework, and like I said, there's another video posted with just examples that go along with your homework that you might find helpful. But please let me know if you have any questions.